Hi guys, today is day 32 and you're looking at 73 and 74. So lesson 73, we're working with exponents and then writing decimal numbers as fractions, part 2. So we've been doing that plenty this year, but we'll get more practice with it. So an exponent, again, you may have seen problems like this where you have a small number in the upper right-hand corner. This doesn't mean 5.2 or 52, and this is where when we're writing out a problem, we want to make sure that we're making our base, which is this number right here, larger, and then the exponent, which is the 2 right there, make sure that it's small so we can see. If we get in a hurry and it just looks like, is that 52? Is that 5 to the power of 2? I've been grading some tests for some of my older kids, and sometimes I can't tell what they're getting at. I'll try and talk with them or give them the benefit of the doubt, but if we're going to hurry and come back and like, oh, is that 52 or 5 to the power of 2? It's going to be very different. And how we read these is we say this is 5 to the power of 2, or to the power of 2 we can call squared. So a lot of times we'll say 5 squared, same thing. 5 to the third power, or 5 to the power of 3. We can also call this 5 cubed, or whatever our base is, 10 cubed, 20 cubed, whatever it is, to the power of 3. Okay, or 5 to the power of 4, or 5 to the fourth power. And all this means is if it's to the power of 2, that means we have 2 5s, and we're multiplying them together. 3 means we have 3 5s that we're multiplying together. 4, 4, and you guessed it, it's going to continue on that way before. So we can go into our calculators and we can do, or by hand, 5 times 5 times 5 times 5, or we can do 5 to the power of 4. And I'll show you how to do that. Okay, so again, 5 to the second power, or 5 to the power of 2, 5 squared, 10 to the third power, 10 to the power of 3, or 10 cubed, 3 to the fourth power, 3 to the power of 4, 2 to the power of 5, or 2 to the fifth power. Again, as long as we say that it's a power, or squared, or cubed, we should know what we're talking about. If we're comparing these, 3 to the power of 4, 4 to the power of 3, which one of these are greater? Well, this is 3 times 3 times 3 times 3. This is 4 times 4 times 4. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. 4 times 4 is 16. 16 times 4 is 64. So 81 is greater than 64. Another thing, if we go into our calculator, I'll show you, I know I've shown you in the past, but how we can do these problems on our calculator. So 3 to the power of 4, we're just going to hit 3. Okay, and then this little up arrow right here is going to be for our power. So hit up, and that takes us, up. So 3 up arrow, and then you see we get to that blinking square in the upper right hand corner. So we're going to put in 4. Important to make sure that we hit the right arrow to get us out of that exponent, to bring it back down. And then we wanted to figure out what that was equal to. This one we weren't multiplying, we were comparing them. And same thing, 4 to the power of 3. 4 up the power of 3. Make sure you get it out of there, because down the road we'll have expressions where we have more than just a base and an exponent. We hit enter and we get 64. We're using this up arrow, that's how we can put them into our calculator. Okay, if we're doing prime factorization of 1,000 using exponents to group the factors, prime factorization, I prefer, there's division by primes. I prefer this kind of tree method just because it visually makes more sense to me. I want 10 times 100 is 1,000, and 5 times 2 is 10. Those are prime numbers. So I'm going over here. 10, I know 10 times 10. I just did that. So 5 times 2, 5 times 2. Okay, so I can multiply these in any order, but I have 2 times 2 times 2. 5 times 5 times 5. Okay, and then how I can use exponents to rewrite this? Well, 2 times 2 times 2, I know is 2 to the power of 3. I have 1, 2, 3. 5 to the power of 3 because I have 1, 2, 3. And then again, well, I mean, there's no way this equals 1,000, does it? Well, let's check. We can always check our work. If something doesn't seem right, we can always go in and check our work. So we just showed you how to use the calculator. So let's do 2 to the power of 3, get out of there, and then times 5 to the power of 3, get out of there, and we get 1,000. So we know we did it correctly. So that's one way you can use the calculator to help you check your work. And so we didn't change the value, we just rewrote it. Now, so we're saying 2 times 2 times 2 times 5 times 5 times 5. We say 2 cubed times 5 cubed. Right, if we get 100 minus 10 squared, again in our little jingle of PEMDAS, please excuse my dear Aunt Sally, we know parentheses are first. In this, I don't have any parentheses. E is exponent, so that's going to be any time I have anything raised to a power or a square root or cube root, which is down the road we'll talk about. So I do this square before, or to the power of 2 before I do the subtraction. 10 squared, or 10 times 10 is 100. So I guess 100 minus 100, and so just equals 0. Put this portion into our calculator if you wanted to, and check it and solve. Writing decimals is a common fraction. So again, we know our place value, we have tenths, hundreds, thousands. So if I have 0.5, that one's not too difficult. We probably know that's half, but we can always use 5 tenths, because this is 5 tenths, this is 5 tenths in fraction form. I reduce these down. 5 goes into both of these, it reduces down to 1/2. 3.75 is a mixed number. It's 3 and 7,500, so I know 3 is going to be my whole number. 75 hundredths is tenths, hundredths, so 75 hundredths. 25 goes into both of these. It goes into 75 3 times and into 100 4 times, so 3.75 is a mixed number, is 3 and 3/4. We use that and when we're saying it properly to let us know that we're talking about the value that's less than 1. So 3 and 75 hundredths, so 3.75. 3 and 3/4. All right, that practice set we will do together. Last one we're looking at is lesson 74, writing fractions as decimal numbers and ratios as decimal numbers. So again, if we just remember that a fraction is just division, 1 divided by 2, do that in calculator by hand, whatever, not too difficult, we get 0.5. We just did the opposite of that last one. Yeah, 0.5 to a fraction, which was 1/2. So if we have 1/4, 1 divided by 4, 4 doesn't go into 1, so we get 0. So use remainders, so put our decimal. So 4 goes into 10 2 times, 2 times 4 is 8, so 2 left over, 4 goes into 25 times, so 5 times 4 is 20. Go until, when we're converting, we'll go until we either have a repeating decimal, which we haven't talked a lot about, but we will, or we have a terminating decimal. If it's written as a fraction, it's either going to terminate or repeat. It's not going to go on forever. So at some point, we will be able to stop. If we're able to use a calculator, which you can use a calculator for 1/4, you probably don't need to, but you could have if you wanted to. 15 16, so 15 divided by 16. 15 divided by 16. Here we get 0.937. Put in fraction is just division, so we just do 15 with our division, 16, and then get our answer. 7 2/5 is a decimal number. 2/5, well, 0, sorry. 5 does not go into 2. So we put a decimal both places. 0. Now 5 does go into 20. 4 times 5 is 20. So that's why I don't have a remainder. So 7 and 2/5 becomes 7 and 4/10. Writing ratios as decimal numbers. Converting ratios to decimal numbers is similar to converting fractions to decimal numbers. Since a ratio we can write as a fraction, it's really going to be the same thing. So a number cube is rolled. Express the probability of rolling an even number as a decimal number. Well, 2, 4, 6 are even, and they're on our numbered cube. Two is even, 4, and 6. So we have 3 out of our total, which was 6. 3 out of 6. 3 out of 6 reduces down to 1/2. And if we want to express that as a decimal, we've just done 1/2. We know is 0.5. But we could do 1 divided by 2 if we needed to go back through that. But it's 0.5. And so ratios, probabilities, we can express as fractions or decimals. Probabilities, oftentimes we use percents. We have a 50% chance of doing something. We express it that way as well. If we want to convert from a fraction to a decimal, we'll just do the division. Once we have our ratio in fraction form, and we go from there. All right, we'll do that practice set together. We will get to lesson 75 next time. So this is all we have for today. We'll go over some of these in class, go over the practice set together, check the homework, and keep moving on. We have a few more lessons to get through by the end of the semester.